Okay, thanks everyone for joining. It's 4:05. We will start the workshop now. Quick introduction. Today giving us this workshop is Chi Chuan, who works at Etherscan. If you've seen some features on Etherscan, such as the token approvals or the ENS name tag, that's coming from Chi Chuan mainly. So today he will be sharing with us some simple things around verifying contracts, why it matters, how to do it, and a walkthrough of one or two examples. And this is the first in a series of workshops that we'll be doing, that will be exploring transactions on Ethereum in general. So do watch out for the other workshops that we'll be doing. Right now, tentatively, we're planning to do it every Saturday, so every 1 week, but it might change depending on circumstances. And yeah, so if you have any questions, feel free to ask in the chat box. I am going to force mute for everyone just to make sure that we don't get any weird Zoom bombing situations. But yeah, over to you, Chichuan.
Thank you, Harry. Thank you everyone for joining. Thank you for your time. My name is Chi Chuan. Today we are going to start our first part of the three-part series. Well, basically the first part is going to be about verifying contracts. So we are going to talk about, I'm going to share about what is verifying contracts for those who are unfamiliar with this term, and where and how do you verify it. So, and what's the purpose of a verifying contract? So before that, let's start with the end goal. The end goal for today will be to deploy a smart contract, a simple one, and to verify in these two sources, Etherscan and Sourcify. So there are two platforms for us to verify contract. And well, at the end of the day, we will see that our code is being published and everyone in the public can take a look at it. So over here, I have a link. And this is an example in Etherscan. I am using Coven testnet of example of the contract that hasn't been verified. So as you can see under the contract section over here, everything in this area, it's bytecodes, basic, well, not very readable to human. Well, of course you can read it, but it's not very friendly, especially if you want to interact with it easily. And if you look at the transactions, I've made two transactions over here. In this case, but in this case, we can still see the function because I actually deployed similar functions to the Etherscan, and it detects that I have similar. It detects I'm using the same function. That's why it has automatically named it. But normally you wouldn't see this. You would see something like maybe this. So it's really hard for people to know like what function am I calling in for this particular transaction if I didn't verify my contract. And if I look at the logs will be something like this. So it will also be very hard for us to understand what's going on if someone have not verified a contract. And let's look at another example of a verified version. It's a very similar contract. So over here, first up, I can see there's a little check mark, green check mark over here. It says that it actually means that the code is readable by everyone in the public in Etherscan. So as we can see over here, we can look at the contract name, the compiler version, and some other details, such as we can go through the code over here. For those who would like to inspect the code before interacting with the smart contract, which is generally a good practice. This is a good way to do it. And we also have the contract API in case for those who wants to build like a project that interacts with the smart contract. People normally gets the contract API and you can get it from here. And one thing about Etherscan is that Etherscan makes things easy to interact with the contract. So every verified contract will have this read and write section. It basically means that without having to code, you can interact with the Etherscan interface UI to interact with the contract. For example, now I can get current number is 8. I'm just reading from the blockchain, the stake, and I can even interact with the contract over here if I want. And you just need to connect to your MetaMask or Wallet Connect. And Etherscan does not store your detail at all, so feel free to use. So this, and okay, let's take a look at the examples, the transaction action. shown here. So you can see that, hey, I'm actually calling bound to current number. Much more current number. You can even view source, and it shows that well, it's calling from here, right? So this is what happens. This is our end goal today. We will try to achieve. Hang on a minute. We'll try to achieve this one in Etherscan. Oops. The verified version in Etherscan. Sorry, wrong button. This one in Etherscan. So we will publish our code to the public so everyone can read and review it if they like. So now that's Etherscan. And there is another version of verify contract that people sometimes would like to use. It's called Sourcify.dev. The difference of Sourcify and Etherscan is that Sourcify is decentralized. They use IPFS to store your contract. So for some people who somehow likes their contract to be in a decentralized manner, Sourcify is the way to store it. And take note that Sourcify and Etherscan, they do not share their contract. So after you verify your contract in one of these platforms, you have to do it another time in the other platform and vice versa. So let's take a look at how Sourcify will look like. Unfortunately, it's down. The fun thing was yesterday I tried to verify contract in Sourcify just to test run this project, but I couldn't get it to run. So I guess if we manage to get to run today, we can see the final outcome. But if we can't, I'm just going to show you the steps of what we need and how to do it. Okay, so this is a previously verified contract. It's a bit slow. It was very slow. Always happens when you want to show things live. It happens yesterday at night as well. I don't know why. Anyway, it's fine. I'm going to show through the steps, and you can just replicate the steps. And if it works, I mean, if Sourcify is back up, you can follow the steps and you can do it. So what I have over here is that I can see that I have a contract, full match contract, in 42, chain ID 42. It means Coven. And this is the contract address of my contract that I am verifying in Sourcify. Over here, they provide you with some folders, so the source and the metadata. The source will contain the contract code. Over here, I store it here. You can see that I'm using Open Zeppelin, and it follows the structure of my folder. Made a mistake by putting it that deep. I have to perform a lot of clicks. Almost there. Okay. Yeah. So there you are. So we can see the code over here in Sourcify, and everything is something to scan. It's just that they are storing in IPFS. It generally means that it's more decentralized. And one thing that is different about Sourcify to Etherscan is that in Etherscan there is a built-in write and read contract feature, while Sourcify doesn't have it. So for those who like to interact with Etherscan, it's better to do it over there, or you can just copy this thing and have to write your own program to interact with the contract. Okay, so that's the final. That's what we want to achieve at the end of the day, to deploy a contract and to show, hopefully Sourcify will work, to show our contract deployed in Etherscan and Sourcify. Okay, and today we are going to use three more mainstream tools to deploy our contract, and which are primarily Remix, Truffle, and Hardhat. We are going to look into 3 of the different methods, and each of them have a bit different, but generally the roadmap is similar. We'll write a smart contract, and then we deploy it using this one, using the method for Remix, Truffle, or Hardhat, and then we will verify our smart contract. So I think we can start with the demo now. So I will start with Remix. So Remix will be, for those who would like to have questions, just put it down the chat box. I will reply if I see it. And I will try to, take a bit of a interval in between to read and probably answer questions if there are any. Okay, so this is the Remix browser IDE. You don't have to install anything. You just have to have a Chrome, and then you just go to this website, and then you can see that it appears, and you can use this to develop and deploy a smart contract without having to install any fancy softwares. So first thing first, I am going to create a new workspace. Let's call it verify, and let's call it workshop. And automatically, it'll give us some basic contracts. I'm not going to use them. I'm going to delete them because I want to make things clean so that it's easier for me to work on this demo later. And at the home page, we can see that there are featured plugins. Over here, we are going to use a couple of plugins, mainly Etherscan. But there are plugins for Etherscan contract verifier. So the verification, you can deploy, you can verify contract through by using Remix plugin. But somehow when I was testing it in testnet, it doesn't work. So we are not going to do that. We are going to do it manually in the Etherscan interface. And there's a flattener, and there's a Sourcify plugin as well. So we are going to talk about Sourcify and flattener later on, but we're not going to look at the scan contract verification because it doesn't work for me in testnet. So I'm going to do that manually. So first up, let's create our own smart contract. Okay, so first off, we have to create a file. I'm going to call it math. Okay. And we are, well, generally there are two types of contracts which you can verify. One is a single file contract, and one is multi-file contract. Multi-file contract is it can be a bit tricky. So for everyone's sake, for today, we are going to use this example for multi-file. And I'm going to use OpenZeppelin's contract library because that is probably the library that everyone is using right now. So for everyone's benefit, I'm going to use that. So first up, I've already written some code snippet on my other screen. I'm going to declare the stuff that I need, and I'm going to name this. I like to follow the contract name to follow the file name to make things easy. And we can actually import OpenZeppelin by pointing it to the GitHub repo like this. But make sure that you include the HTTPS, and then it will work. And for the code snippet, okay. And okay, so what I have here is that I have declared some events which I'm going to emit later. We'll talk about events in future workshops. But for now, just remember, just bear in mind that we are going to emit events, and there are some write contract functions and read contract function. One read contract function that we are going to deploy. So once we have everything, we are going to this part and ensure that the compiler version matches to this thing. So this is 0.6 above 0.6.0, so I'm going to 0.6.12 because I tried it and it worked. And I'll just compile it. And then you can see that everything works now. So I'm going to head back to the workspace. And after compiling, we can see that in the .deps file, in the Git, there's a new folder here. It's called GitHub. And inside, there's an OpenZeppelin contract, safe math, that we are using, which is this one over here. Can I please zoom a little bit? Can I zoom? Is this helping? I take it as a yes. All right, no problem. Cool. Where was I? Yes. So once I compiled the contract, Remix automatically gets the file from this link, and you can see it appearing in our workspace file explorer. Okay. And now we have compiled it, so we are now going to deploy it. I'm going to choose MetaMask. Oops, wrong one. MetaMask is injected for 3. Forgot to log. Okay, I'm using Coven. I have plenty of Coven Ether. And well, after it's done, we can deploy it. Okay, MetaMask will prompt me, and I will accept. Okay, over here, we can see that our contract has successfully been deployed. Copy that, and we just go to Coven to see, look at our contract. So over here, this is our contract that I just deployed 16 seconds ago. As expected, this thing is a bunch of bytecodes that is not really readable. So we can verify and publish it. But we actually can't do it because we are using, hang on a minute, we are using this one. Although Remix supports importing file from a GitHub link, Etherscan verification for multi-file does not. So we have to find ways to overcome this. Of course, in Truffle and Remix and Hardhat, there are better alternatives. But looking at Remix, we have to look for workarounds. So the first workaround is that we are going to flatten the file. By saying flatten, it basically means that we are taking this part of the contract and we just copy paste it on top of our math contract underscore remix file. So basically we are combining multiple files into one huge Solidity file, and then we deploy it as one file. So let's do it. I already have my flattened file here. So after you have deployed it, you can click this and save as. All right, over here it says that I have already this file. So if I go to my workspace, this thing should appear. So note that now the save math file, it's this one, library. And at the bottom, we'll have this contract underscore remix that math contract underscore remix that we just wrote. So we are going to try to compile this to see if it works or not. And it will not work because one thing about flattening file is that we have to take care of the licensing for both contracts that we are flattening. So on top here, we can see that this thing already has an MIT license, and over here there's another. So we cannot have two licenses at one place. So we're going to just remove this one. And we'll remove this one as well. Okay. And after we have removed this, we can compile it successfully just like this. So the difference between this flattened file and the one before, it's that now everything is in one huge Solidity file. Yes, double blackslash is a way to comment in a Solidity file. And yes. So now we are going to deploy this, and we are going to verify this as a single smart contract. So I've already compiled. I'll throw this away to keep this clean, so I don't confuse myself. Deploying it again, and just give it a bit of time. And yeah, there we go. We have successfully deployed our contract. Just going to navigate to the address. Takes a while to show up, but it's there. Don't worry, it's there. Yep, it's here. So now this is our contract that we are going to verify. And before I do that, there are two things that I need to I have to take care of. One, I have to know what version that I'm using for compiler, and the other one is whether or not have I auto compile. Have I selected the auto compile option for my for when I'm deploying this? So I have not. So after that, you just click this button here. Well, how did I replace the GitHub link again? I actually did not. I flattened the file, and the flattener automatically copies the code over from the GitHub link smart contract and append it on top of the smart contract that I created, and then it creates a new flattened version for the file, which now I've just published. Can address be also a wallet and contract at the same time? No, it cannot. What does optimization refers to? Optimization basically means that it uses the Solidity compiler to try to make your code more optimized, so that when you interact with it, it actually saves gas, at a cost of sometimes making the code a bit more unreadable. So for small contracts, it shouldn't matter, but for big contracts, maybe it's a worthwhile thing to do. So it's always better to allow it. Well, at the expense of making it hard to read. How does one deploy contracts on different networks with the same address like 1 inch? That is a good question. Something that I have yet to figure out. I'm pretty sure they use this thing called create tool opcode. I'm not very sure, but create tool opcode allows you to predetermine the contract address before you deploy. So I think it has something to do with it. Not too sure of the details. All right, so let's proceed with our verified contract. So over here, we select single file and compiler version. I chose 6.12. This one I can follow back, or I can, yeah, it's very optional. I just follow back MIT because I used MIT before. Continue. And over here, make sure that this thing follows our configuration that we had before here. Okay. And we need to enter our Solidity code. So we have to copy exactly what we have over here and paste it here. And just verify it. Thanks, Caleb. So it takes a while to verify. And after doing it exactly, and we have the code, you didn't change the code when you copy and paste it, it will show you a success status when you can go to your contract and you can see that now indeed you can view all the codes, and then you can interact with this one over here. Okay, so this is how we do it. Option number 1, by flattening the file. But sometimes flattening the file may not be a good option because, for example, what happened if we were to let's go back to our contract first. Here, what happened if you were to use like a lot of imports? We are using a lot of OpenZeppelin file, for example, safe math, and probably there are other things like maybe ERC20. There are maybe 5 or 6 imports, sometimes up to maybe 10 or 20. And what happened if we have import within import? So everything is going to be quite messy, and flattening the file it's quite hard to read. It's one long big file. So we still want to deploy it as a multi-file, and we can't do it this way. The thing about Remix is that, well, you can't do it this way, but the thing about Remix is that you will need to then create another contract. I will show you. It's easy to show. I'm going to name it exactly how I name it to save math, and I'm going to copy over this file that I have from OpenZeppelin. Copy exactly, paste it here, and in my original thing that refers to GitHub repo, I am going to be pointed to my local instance of a source safemath.sol file, which is this one that I just copied over. So it will work exactly like the OpenZeppelin version, except that now instead of pointing to the GitHub, we are actually cloning it, copying it to our local workspace, and then we can compile. Okay, and it compiles successfully, and then we can deploy. I will just clear everything. So we deploy. So the trick is to change the import to the local instance of the file instead of referring to the github.com. And let's go here. a while for this thing to appear. All right, this is a multi-file. So when I go to here and try to verify it, select Solidity multi-part files. 6.12. This one I can just choose whatever I want. Okay. Over here we will need to upload our file. Make sure the optimization is the same as when you compile it. So I'm going to upload the file that I have deployed, which are this one and this one. So I'm going to basically download these two files into my local workspace. There's a simple way of doing it. I can click this button over here, click, and download all files. You just zip my file. Hang on a minute. And this is a file that I just downloaded. Yes, you will be in workspace, this workspace, and it's going to be these two files that I'm going to use to verify. So now I already have this. Let's copy this path because I will need it here and upload these two. Upload. Okay, now I've uploaded successfully these two files and verified. Yeah, it's going to take a while. Right, as you can see, it is successfully verified. Let's take a look. So over here, this thing is really referring to our local softmath workspace, and this is our softmath file. So as you can see, we have deployed a multi-part file. This thing is something that this function is going to use, and everything it's exactly as I want it to be. Okay, so this is how I verified single part or multi-part contracts in Etherscan. And let's try and see if Sourcify works. I can use the Sourcify plugin. Coven, because this is Coven. Is this common or safe? How can you be certain that the local file was not modified without going over each line? You can't. You have to ensure that the person who deploys it doesn't tamper with the local file. So maybe you can use the contract difference feature in Etherscan, or you can just copy it to text file and see if there's any difference in the lines. Yeah. So have to be sure that the library that people are using has not been tampered with, so to say. So yeah. So over here, I'm going to copy this address. Can. Let's see if it works, because it doesn't work for me yesterday. So let's see if it works. It's very simple. I don't think it works. Anyway, while this is waiting, there is also another way to verify files in Sourcify manually. So this is the main page. You need to go here and paste my contract, which I just deployed. Oh, Sourcify is really, really slow today. I wonder what's up. I'm going to ignore that. I assume it's down, but it's down. And to verify it, you need the smart contract and also the meta JSON data that comes with it. What are these? What are these? The smart contracts are. Let's get my sample. No, wrong file. Sorry. Yes, this one. So these two are the smart contracts which I will need to put in Sourcify. I'm going to just do this for show. The meta JSON data will be something that looks like this remix metadata. So inside, inside it has, ignore the other side. Inside it has some details which Sourcify might need, such as what are the functions, and stuff. So you'll need to upload this file as well. I'm going to throw it in. And once it's done, you can just click verify and it will verify for you. But Sourcify right now it's down, so you have to wait for it to go up to do this step. But these are the general files that you need to verify on Sourcify. Okay, so that's all for the remix part. So to recap, what have we done in remix? So we have created a simple smart contract with fuck events, that emits events. We have import library using OpenZeppelin, and we try to verify as Sourcify. We have also flattened it and try to verify as a single file Etherscan. And then we change the import to point to the local file, and then we verify it as a multi-part file in Etherscan. And we also seen how to manually verify the smart contracts on Sourcify. So in Remix, this is what we have covered and how it's done. How it's done. Okay, so moving on, there are two more things that I'd like to show you. The other one is for those who don't like to use Remix for their own reasons. There's Truffle that is also a common tool. So let's create a simple Truffle smart contract. Truffle. So let's use Truffle to create a simple smart contract, and I will explain what are the things that affects us. So yeah, let's get okay. So if for those who have not installed Truffle and other prerequisites, you will need to install those, such as Truffle in a global as a global package, such as a Node.js of I think version 12. I'm not sure. You can check it out in the official site. But after that, you can start. Then let's create a new folder. Let's call it F Truffle. And inside, I am going to run some commands. The first command will be truffle init. It will initialize a simple truffle style truffle the stuff that we need for truffle. The most important thing will be the truffle-config.js. I will show it later. And we'll need a package.json file. I'm using this because I don't want to create manually. And this one will create a package.json file for us. And then because we are going to use OpenZeppelin, I'm going to install OpenZeppelin. OpenZeppelin/contracts. I'm going to save it. Okay, now that once that is done, we can. I like using Visual Code, so let's open in Visual Code. The screen. Etc. Okay, what have we done just now? So first, we have installed OpenZeppelin contract, the npm package. Second, we have used the npm init to create this, to bootstrap this truffle config.js for us, which we'll need to change. And this truffle config.json will specify the compiler version and also the network that we will use. And there are some other features such as this for testing, stuff that may be useful for you, but we will not go too much in detail. And it also nicely structured the project files for us. We have contracts, we have tests, migrations, and we won't be using tests. And it has written a migration script, which we won't be using. We'll just delete it. Okay. So slow, sorry. Instead, I'll be creating a new file. my Visual Studio hang? All right, got it. And I'm going to, again, similarly, declare the license and declare the compiler version. And when I see this, I just remembered that I didn't change my compiler version. I'm going to change it here. I'm comment this thing. 8.0. I'm going to use 8.0 because I tested it on 8.0. It works. Save it. And then we can import Purple Zeppelin like that. It refers to the package that we just downloaded, and then it goes to where safemath.sol is located. And I'm going to give it a contract name again. And over here, I'm going to paste the code that I've written. Again, this is a very similar code which I'm using for Remix. I used just now for Remix. It has events, it has setters and getters function. So that's it. Then we can now compile it. So to compile Truffle, it's Truffle. The command is Truffle compile because we have already installed Truffle in our global path. Oh, I forgot to save it. It might fail. Oh, it did not. Nice. Just to be sure, I'm going to compile it again. Okay, awesome. Once it has compiled, we can check our build folder to see if everything is correct. It looks correct. Okay, so we're good to go. So now we are going to deploy it to our network. But before that, we will need some more libraries. One library that I will need is this Truffle HD Wallet Provider library, which helps me to select the account that I want to deploy using by passing over the private key. You'll see later. Okay. And now, while that is downloading, we can head to the traffic config file. We are going to change some things over here. First up, we are going to include it's fine, I'll just leave it over here. We are going to include this thing that we are downloading, and then we are going to pass in the private keys and the Etherscan API key. I'll explain later what is that. From a file, it's got .myprivatekey private key.txt, which I have not copied over to. So I'm going to do that now. Let's see. Okay, so I have prepared my private keys and place it in this folder, and these two are my private keys for Etherscan and the account that I could deploy using. Okay, I'm not going to expose it, so I'm going to put it into one file. The other better way is to put it in your environments. Too much of a hassle, I'm not doing that now. Okay, and then this one is right. We have imported our keys. Now we need to add the network under the network area. So the network we are going to use is Coven. Paste it here. Okay, so Coven, this is going to be my provider. Oh, I actually exposed my my Alchemy API key here, but it's fine. I'm going to delete later. So I'm using Alchemy, by the way, and you can get the API key for free in their website. Okay, of course you can use any node. Yeah, you're welcome, Caleb. And network ID 42 for Coven, and all these things we can configure. These are the default settings. Okay. And then before we deploy, we will need to go to this place. Truffle has this thing called migration script that we will need to change. So by default, it deploys the migration.sol file, which I just deleted. It's no longer there. So I'm going to change it to deploy to the Truffle map file that I just created. So name of the contract. Just going to change this. Okay, that's how it will look like. Okay, so it basically means that we are getting the artifact from, save this. We are getting artifact which is here. Wait, hang on. Yeah, here. We are getting this. And then we are going to deploy that file. Okay. So once we have the migration file, we have configured the configs. We have already compiled this thing. We can migrate it. So the command will be truffle migrate, and I'm going to specify my network. The name of the network follows the name that you define in the config. So covert was something I defined just now, so I'm going to use covert. Okay, so you can see it's running this migration script. It's going to rely on this to deploy it to the network that I chose to deploy to. Takes a while. Sometimes it fails, so it's okay. Just try again. All right, now it's deploying. All right, there we go. We have deployed our contract at this address. So let's go take a look. Here. I won't be needing this now. Okay, so this is the contract that I just deployed 21 seconds ago. It's by me. This is my smart contract. My address, and it's smart contract I deployed. So now our task is to verify this. One good thing about using Truffle to deploy contract is that we can rely on some Truffle plugins to verify contract. So we can use this plugin. Oops. Wrong one. See, it's called a Truffle plugin verify. Save it. Okay. All right. I'm going to check. Yeah, it's indeed here. It's in my dev dependency. Okay. And now in the Truffle config file, I am going to let Truffle know that we are using this plugin. So there's this thing that we use. Okay. And then we need to specify the key that we are using. So we'll be doing this. So it tells the config that we are using this plugin, and we are passing in the key from my priority key folder for its API key. And once that is done, you may run Truffle run verify, and then you specify the name of the contract that you publish, and then you specify the network. Oh, I forgot to mention, for those with constructors, you can pass in the arguments behind this line. We refer to the libraries, the GitHub repo of Truffle plugin to see how it's done. Okay, nice. Successfully verified, max limit reach, successfully verified one contract. Well, let's see if it's successful. All right, indeed, it is successfully verified by using the Truffle library. Okay. And for the sake of completion, we are going to verify to Sourcify. But the thing is, Truffle doesn't give you the doesn't nicely give you the metadata.json file. It's nicely hidden here in truffle.json. And you have to go and find the metadata function, copy this, right? Copy this part, and then rely on some, I'm no longer using this, rely on some online tools, string unescape. Go. Unescape. And you copy this. Fine. Formatter. Oops. I forgot to copy it properly. I did, right? Yeah. Never mind, let's try again. JSON formatter. Yes, I did. And this is going to be a valid JSON. So we can download this JSON and it will give us the metadata.json file. And in Sourcify, we can just paste the metadata.json file along with the two files which we created. Okay, and that will work. And we can see that Sourcify now it's down, so we won't be using that for now. Unfortunately for Truffle, I couldn't find a nice library to use to verify to Sourcify directly. You have to do it the manual way, but that is fine. Okay, so that's all. And also the flattener doesn't really work well with the libraries such as OpenZeppelin. Try it, just doesn't seem to work for me. Okay, and a quick recap. It's for Truffle, we have used the OpenZeppelin npm package. We have a quick tour in the truffle.config.js file. Deploy the smart contract and verify it on Etherscan using the plugin. And we see how to extract the metadata from the Truffle build files and to try to verify it on Sourcify. All right, so we have completed Remix and Truffle. Last one remaining is Hardhat. Hardhat is also a very commonly used tool. So let's go and do it. First, I'm going to create another new folder. Where's my new? Yeah, tape. Okay. And I am going to run. One thing to note is a Hardhat. There is an official way. We won't be using that. We'll be using this library, which is built on top of the official library, because this library gives us a nice plugin to use to verify on Hardhat. I mean on Sourcify. And there are also other functions which are kind of nice to use with this library. So generally, you can rely on this third-party library to develop on Hardhat. So I will first init package, and I will need to save install Hardhat to my dev dependency. It's a bit slow because the file is a bit big. Right, bear with me, guys. All right, it's downloaded, so we can again open up with Visual Studio Code because I just love using Visual Studio Code. Let's see if we have indeed. Yep, I already have this. I have installed this successfully. And next up is we need to create a config file similar to the Truffle file, and it's going to call hardhat.config.ts. TS stands for TypeScript. You can use the JS file as well, but because this package, this third-party package that we're going to use has types, so I'm going to use that. Oops. The content of the file is actually rather similar to the config.json in Truffle. I'm going to first import my keys here, and the config states the Sourcify version, the source file of my contract, the Coven network that I'm using along with the private key, and the API with this API key, and this is going to be my URL, the node. No point hiding it out because I showed you guys just now, but it's fine. And because I'm using TS, I will need to create this thing called a tx.json. Okay, sorry. Yes, that's correct. This here. It's just telling my Visual Studio that I'm going to use TS, and then there are some dependencies which I need to download. The Hardhat deploy dependency, TypeScript, and OpenZeppelin contract. So while that is downloading, we create a folder, the source folder, because we are going to run our contract there. Oops, created the wrong thing. There you go. So this is where we are going to write our contract in because we have already declared here. Okay, and now we are going to follow back the contract that we just deployed. So I'm going to call it math contract or Hardhat. So we're going to copy this one. Again, similarly, we import OpenZeppelin by referring to the npm package because that is where the contracts are being stored. For those who want to see, it's right here, utils, right? Utils, math, and there are lots of contracts that we can use in OpenZeppelin. I'm only using one of the many. So yeah, this file, this file to be exact. Okay. Right. I'm going to hide this thing, it's too big. Okay, I'm going to continue with the rest of my contract. Okay. And copy the contents over from my prepared code snippet. Right. So again, it's the same file. I just changed the contract name. And once that is done, npx to compile the contract, and you automatically read the config.js and let us know what happened. Oh, I forgot my private key folder. Let's see here. Hang on. Just going to copy over. Okay, there you go. And we can try again. So now that is successfully being compiled. Now we can see there's a new folder, artifacts. And over here we have our build artifacts, stuff that we need to deploy. Okay, cool. Once that is done, similar to how Truffle is, how Truffle works, you will need a migration script. So we are going to create a folder. It's called deploy because by default, Hardhat reads from the deploy folder. In Truffle, it's migration. Then I'm going to create a new file, just randomly name. Okay. Just want to copy over this script. It's just telling us that we are going to deploy this contract with this name. Obviously, the name is okay, not the same. Let me make it the same. And there you have it. Now we have changed the config. We have created the deployment script. We have compiled our project. Now we can deploy it to the Coven network. So the command will be over here. Just deploy, and yep, we can see that this has been successfully deployed. I'm going to copy this and go back to our Etherscan page. Yeah, it takes a while to reflect, but you'll be there, don't worry. Ah, yes, there we go. Yep, we have just deployed this 30 seconds ago. Cool. So now, the good thing about Hardhat is we can use the library to verify on Etherscan and also on Sourcify without having to do things manually. So because on Etherscan we have really defined the keys that we need. Like here is the key. So all we need to do is that we just rely on Hardhat again. Coven, because we deploy in Coven, and we use the library Etherscan verify. Okay, just give it a while. All right, over here it says that this contract is now verified. So let's see if it's not lying to us. All right, indeed, this contract has been verified by using the Hardhat method. So for how to get API key, you go to etherscan.io, you create a free account, and over here, you can create up to, I think, three free API keys. Creating an account is free. Everything is free of charge. Okay, finally, how do we how do we verify contract on Sourcify? So there is also a handy command that I can use. And I just type Sourcify. There you go. Because Sourcify is down, so this thing will not work. But if it's working, you can see that your contract can be seen on it can be seen on Sourcify. Yeah, it says that Coven doesn't is temporarily unavailable. So yeah, that's Hardhat. So final recap, for Hardhat, the config is similar to Truffle's config. We create and deploy smart contract. We take a look at the third-party Hardhat deploy library, which has nice tools to verify contract on Sourcify, and we can do that by using the Hardhat commands. So I think that is all for verify contract on using three different methods. Any questions?
I think people can raise hands, and if you raise hands, I can unmute you. Okay, Cedric has a...
Hey, hello, thanks for the quick walkthrough. I have two questions. So I was trying to compare some of the Yen contracts. They are verified on Etherscan, but they are not verified on Sourcify. So I actually, before you started the thing, I was just wondering, this is a choice, right? Or is it kind of like you're not required to verify your contracts on both platforms, correct?
Yes, that is right. That is a choice. I think in Yearn's contract case, they just I don't know. I'm not sure why they do not want to verify on Sourcify.
Yeah.
Maybe they think that verifying Etherscan is good enough because maybe a lot of people likes to interact with the Yearn contract through the UI. But it's definitely a choice. You can choose not to verify in any of the platforms. It's totally fine.
Right. And then with a verified contract on Etherscan, you can really interact with the read and write functions or immediately, right?
Yes.
But that's really more on a sandbox. You kind of don't want to interact with individual functions in case it's like destructive.
Yes, that is correct. You might not, for example, let's say this contract has a self-destruct function.
Yeah.
Well, the function will still appear here.
Yeah.
But it is the programmer's duty to ensure that this function can only be called by, for example, the deployer of the contract. So
Right.
even though, let's say it's available here for the public to call, even though if I were to call it and I'm not the deployer, it will reject my my transaction.
I see.
Of course, gas will still need to be paid because I executed something there.
Yeah. But this is really just for like if you are a dev and you're just trying to test some of the functions. But if I'm trying to verify a contract that belongs to Yearn or Aave, for example, I shouldn't be actually doing this by calling individual read-write functions here, right?
Are you trying to? Are you in this case? Are you the Yearn smart contract writer, or you are trying to verify on their behalf?
No, I'm a guest. I'm trying to audit. I'm trying to read their source code and verify that it does what it's supposed to do, or try to develop test cases and find the edge
Okay.
cases. Yeah.
So for that, you can just maybe normally they will have a GitHub page.
Yeah.
If it's GitHub page, it's great.
Yeah.
If not, you just copy everything here.
Yeah.
And then maybe use Hardhat or Truffle.
And run it locally.
And yeah, run locally. You have to compile it, and then you can actually write test case in Hardhat or Truffle where you can just test it.
Yeah. I was just trying to not have to do that.
I think there's no choice.
Okay, cool.
Hardhat is a nice local. You don't have to connect to any node. There's a Hardhat local network that you can interact with, and you can even give your account some Ether, something like that. So there are some nice features in Hardhat. Not very sure about Solidity. I mean,
Okay.
not really sure about Truffle, but I
Okay.
think the similar thing can be done.
I was hoping that you have like a stop point, like a pry kind of a function where I can execute a single function in isolation just to see what the outputs are without having me to run the full integration task on top of it.
Well, you need to write the test case and you need to
Yeah.
copy the state over and then you have to run it. That's how I would do it. Maybe there's some other more advanced methods.
Okay, cool. My second question is simply, I understand why multi-contract is not supported on Etherscan. Is it something that's technically not possible, or is it just not a feature that you have today?
Technically it's supported on Etherscan, but it's just that when we calling GitHub, the HTTPS, right? We are basically what Remix does is that it will go to the GitHub page and it will download the file.
Yeah.
And then you will just make it appear in the workspace. By Etherscan, they are not doing that. Maybe because they don't want to download stuff from random links.
Right.
That is currently not my position to answer.
Yeah,
I'm just guessing.
Do you mean your team or do you mean something else? I'm just trying to understand what happens in the backend.
Probably. Subject to discussion. We can.
Yeah.
I'm not sure how.
No worries if you can't go into that part of the discussion.
But I would imagine, my point of view, my words are not Etherscan's words. My point of view is that randomly downloading files from the link may be dangerous.
Okay.
Because some files may have virus. So if you put a link there, we just download it, it's dangerous.
Okay, thanks.
Yeah, so it's more on a security measure, I would say.
Okay, cool. Just my earlier question was about the verifying that the copy paste local file is exactly as the source file that you download. I just wanted, if you don't mind showing us how that's done, or is it just checking the SHA hash of the two files?
You mean for users perspective, in users perspective?
Well, if I look at someone's contract and it says that it's using safemath.sol, right? But
Right.
how do I know that that is exactly the safe math that's provided by OpenZeppelin if they did the manual copy paste method that you showed earlier? Not copy paste, but basically like copy and pasting it into local file. How do
Yes,
I
I
know
get-
for sure that this is exactly the same?
Yes, I get a question. It's a perfectly valid question. Over here, although this thing is here, right, it doesn't really mean it's importing file.
Yeah.
People can alter this. So the only way for you to go is like you copy the OpenZeppelin safe math file,
Yep.
and then you copy paste this thing. Maybe use some online file checker tool or something. File checker.
I mean, I can just do a diff between the two files, copy over them, right? But I was just wondering why doesn't Etherscan preemptively, because OpenZeppelin libraries are commonly used if you can just simply provide a SHA checker on the contracts safemath.sol against your own local copy, your own private copy of the safemath.sol, and just provide to the end user that, hey, this SHA checks off. That means that it's copied and pasted correctly.
I think that's a good idea. But I think that's a good idea. Definitely would consider, right, Harif? And also we have a contract difference checker you may want to check out. I think it's something like something that you may want to use. It's not as nice as the SHA thing, but you highlight out the parts that are different. So you can definitely check out this page. I'm going to share this link. But it's a good suggestion.
Okay. All right. Cool. Thanks. Just
awesome.
Curious.
No problem. Yeah.
Okay, Caleb, you raised your hand earlier. Not sure if that's to ask a question or to elaborate on the earlier stuff.
Just answer a few questions from earlier, but we can take the questions from the floor first, and I'll round back to that.
Oh, thanks, Caleb.
Is it possible to show multi-file, kind of the difference between one single file and multi-file on Etherscan, like an example of a contract?
I deployed a few. I need to find back. Can be done.
We did mention going through read and write contract, just to like what you can do with it and how it works on Etherscan.
Okay, sure. Right, I'm gonna use this as a multi-file reference. Let's see how many contracts have I deployed. Probably this one. Oh, this is not verified. Maybe the second one. Yep. Okay, so this is yes, I was right. So this is the single file. And this multi-file, we can see that's file 1 out of 2. The first file is being safe math. The second file being the math contract that we're really interested in. And this is just one file, and with everything being combined in a single long file. So these are the differences.
And you can also search the source code, which also works for multi-file.
You can. Oh yeah. You can. Let's try it. So we can search for function, but to search, right, you need to go to the specific file that you're interested in. So
no, Chichon, you go slightly above the search source code.
Oh, you mean this one? Oh wait, hang on. I know what you mean. Here.
Yep.
Cool. Okay, let's try. Okay, bad idea to look for. Yep, you can. Right, cool. Forgot about that.
Yep.
And there are nice functions for multi-file and a single file where you can just copy the entire source code of this file, or you can even generate permalink. For example, if I want to go to this line, I can generate permalink and paste. It will go. You go to this line and highlight this line, so it's a nice thing to share.
Yeah, so we can run through the read and write contract.
Okay. Okay. Since I'm already in this contract, I might as well use that, right? Okay. So currently, the current number is 1. So let's try to play around with this number. What can we do? There are 3 functions that we can call. Let's try to add like maybe 5. So 1 plus 5 will be 6. Oops. Confirm. Okay. Take a while to
Yeah. And it's not just for like simple use cases like this, but you can also use it, for example, to execute a swap on Uniswap or any other DeFi platform. If you know how the functions work and what parameters needs to be put in, then yeah, even if the website for the DeFi app is down or for whatever reason, let's say Andre deploys a new contract and you know how to use it, then you have a big advantage for using right contract versus others.
where can we learn how to interact with smart contract on swaps? What swaps are? What platform are you referring to? Let's assume it's Uniswap V2. Then you can go to the Uniswap V2 official documentation to probably learn more about how they input the parameters.
Specifically, each contract will work differently unless they're literally cloning from each other. So maybe like Uniswap V2 would be one that is useful to know how it works because it applies for a lot of other contracts. I believe so at least. But yeah, so you need to like know exactly the specific contract and the parameters to know. So it's not something that you can just like use for every other contract.
Unless it's something as simple as this, which now that you mentioned it, we can go to add contract number. Then we can look at what it does. So it's basically taking the current number and add it and return it. So that's all. Okay, we forgot to check the results. So we need to refresh this page. And yep, we have changed the state of the smart contract.
Yeah. Teacher, do you think it might be cool to show recontract for example, for Uniswap V3?
Yeah, it's great.
The NFT. You familiar, right, with the like base 64 and all that stuff?
Yes. Let's try to find a token ID. Are you willing to share your token ID?
You can search. You can search from inventory.
Okay.
Random.
Because Uniswap V3 is a very common contract, right? And Etherscan has tagged it, so we can just go to Etherscan Uniswap V3 and FT. Nicely tagged, and then you can search it on Google search. There you go. And this contract, it's very complicated. It's very complicated. There are 55 files. First, let's find something that we can use. Let's see if we have the min.
You have to click inside there.
Yeah, the tricky part about this is that everything is multi-core. I need to click inside. This is not min, but
I think it's
I can have the token ID. Doesn't matter. So, Harith, what do you want to do again with this?
Let's say we want to see the image and the details and the token URI.
Okay, because I've played around with this contract, I roughly know what function to call. So bear with me. Over here, there's a token URI read function. You just paste the token ID which I just copied. For those who want to know more about token ID, it's something that do with NFT. Something that's beyond this scope for now. And I read it, right? And you just give me a long base64 details. Again, this is gibberish to human eyes, and so we need to convert it. So base64 decode. So by using this online base64 decoder, we can decode it. And this is actually a JSON, but it's very ugly. Let me try to beautify it. And there you go. This is the content of the JSON. So this guy has a position in Uniswap V3. It's for the 0.3% fee. The pair is USDC and WEF, and this is the lower and upper limit of the trading pair. The pair, and it's a nice description. And this is the pool address, and yeah, more details. So how do we get the NFT, the image? Let's copy here. I'm doing right, Harif. Copy this one, right?
Yes.
Sorry.
I keep forgetting there's a bit of a tricky part where certain parts you need to copy or not, but I think that should be correct. Go all the way to the end.
It's very hard to copy. Fine, I'll just do it like this. And then, do I decode it?
Yes, to SVG.
So I have added, this thing is not needed. Okay, let's see. There you go. So this is the content of the NFT. It has included a nice image for you, which you can decode it, and it shows this image.
Yeah, and this is just one example of how you can use the read contract function. So you can use this for generally any contract as long as you know the parameters, both to read a contract and to write or to execute using a contract.
Okay, let's see, what can we do? So what can we write into this contract? Yeah,
okay.
You can ask.
We have a question. I'm gonna allow you to unmute.
Hello, Chichuan.
Hello.
I have one contract, right, that I tried to read, but it says that the contract creator didn't provide the ABI or something.
So
in that case, how do we read a token ID? Let's say I want to get the metadata file. I want to know the token URI, right?
First of all, I would like to know what contract is that? Has it been deployed to the blockchain?
Yeah. So hold on, let me just give you the link.
That'd be nice.
Yep. Hold on a sec.
Is this image that you are?
Sorry. I pasted the wrong thing.
Okay.
Sorry. Hold on.
That's fine.
Let me find the contract. Why is that happening that way?
Let me take a look at your contract first.
All right, here's the.
All right, cool, got it. Okay. The problem of this thing is that this thing is not verified, so you cannot. There's no way for you to see what's in it, and therefore you cannot read. There's no way to know the read and write functions unless maybe.
Okay, so in theory, right? Because this NFT is being indexed in OpenSea, right?
Yep.
So the OpenSea must have known how to get the token URI. So there must be a way for us to find the token URI.
I would guess that this is a very common contract. And maybe someone deployed it through some. Oh no! Let's see what's this. I'm doing some digging here. Yeah, this guy deployed the contract, but he didn't bother to verify it here.
Yeah.
And probably because one thing about ABI is that, right, you don't need all of the ABIs to be able to interact with the contract. What do I mean? For example, if we take a look at our math contract here, I have all these functions, right? I have add mouse. No, sorry, these are events. I have get current number. I have multiply to current number. I have subtract to current number. I don't need all of these. I only need the ones that I need. For example, if in this contract I only want to add the current number, and I can just copy this part over, and I can just call the function. That's all. But you can interact with this contract, but you have really no idea to know what's going on inside this contract, because I'm not familiar with this date token. So there's no way for me to know what happens if you call the functions in there. Yeah.
So if it's a standard contract, then you can just try with the token URI method, right?
Because the token URI method is created exclusively on Uniswap v3, so maybe this contract it doesn't have the token URI function read function, so you may not know.
Oh, okay. All right, thank you.
Yes, no problem. If hypothetically I join a token pre-sale and developers try the rug pull, can I interact with the contract directly to swap out my tokens before they do it? Yes, you can. You have to do it before they rug pull.
It also depends on the exact contracts that are used by the specific token or project. There have been cases even we've heard where someone created, let's say, a yield farm, and they essentially copied it from someone else, and there was vulnerability found. So in the original contract, so people who know how to take advantage of the vulnerability just go to write contract and kind of spam to take advantage of that vulnerability.
Yes. So one thing to note that cloning contracts are very easy, but what happens if you are cloning a contract with bugs? It may happen to, if all these projects are cloning from the contract that has bugs, all these contracts has a potential same threat and susceptible to the same attack, so to say. So yeah.
Okay, I think Caleb, you can share on some of the earlier stuff.
Right. I guess what I can do is I can just briefly give a background now on how we do the contract verification. So if anybody has any issues in the future, hopefully this would help you guys debug easier. Essentially, what we do at the back is very simple. We just compile your contract at the back and we do a bytecode match. We would discard the metadata specifically because the metadata also assumes some of the things that your local machine has. Say, for example, the path which you are compiling the contracts from. So we really cannot depend on the metadata for our sort of comparison. What we do essentially is to compare the bytecodes. So as long as you can consistently reproduce the bytecodes with your bunch of SO files, you should be able to verify your contract. Now, to some of the questions which have been asked earlier. So for example, if you want to deploy the same contract address across network, it's possible. I can share a link here. It's, I mean, you can give it a try yourself, just create new addresses, and after that, start deploying contracts on different networks, and you will be able to see how it happens. The idea is basically, if you want to create a contract, the contract address is determined by an element in the transaction called a nonce. So as long as your nonce is the same across the different networks, you will be able to generate back the same contract address. Other ways would be to use create2, for example. Create2, you would be able to more deterministically generate addresses which you had used before, for example. But yeah, I mean, this is a feature which Ethereum itself already had. Just that if you pass through the nonce, then you would not be able to go backwards. If it's a forward nonce, then you would be able to eventually generate to the address. I've seen what some developers done is that they deployed something supposedly to be on Coven or Rinkeby, then they end up doing it on mainnet, then some funds got stuck there. So that actually happened before. So what they had to do on mainnet, what they had to do is that they had to increment the nonce in order to reach back to reach
nonce.
Yeah, that particular nonce, then create a contract on top to retrieve back the funds. Things like that have happened before. But in essence, that's basically how contract address generation works. You have the nonce, you create a contract on it, then after that, you would be able to get back the same contract address.
Awesome, thanks, Caleb.
For optimization, it's interesting. Optimization, so optimization has two elements to it. So one is whether you want to turn optimization on or off. The other one is runs. So how many times you want to run optimization. Actually, the on and off one, I think it's quite straightforward. Then the optimization runs, that one is needs a bit of intuition. So the runs actually refer to how many times you expect that particular contract to be interacted with in its entire lifetime. So if you're expecting people to, say, for example, if I'm not mistaken, the one inch contract has a huge number of runs, I think 10K or something. I could be confusing it with another contract, but I think it's nearly 10K plus. But the idea is this: the more runs you're specifying the contract to be optimized through, essentially it would be cheaper to interact with the contract. The bytecode size would be larger. It will be more expensive to deploy, but it'll be cheaper for the users to interact with. But instead, if you want to, like, say, for example, optimize for deployment, so ensuring that the contract is as small as possible during deploy time, you essentially just put the optimization run parameter to just 1. So that's basically the idea. So depending on your use case, you might want to tinker around with the runs parameter. Any questions so far? Otherwise, I'll move on to other questions. How far can we optimize as to keep it usable? I've seen up to 10K. I think I've seen one case where it's 100K before. You can try different ways. 10K plus, that's quite common actually. I think I've seen more than one contract, but more than 10K, I don't quite see that often. But the idea is that it just depends on your use case. I mean, worst comes to worst, in the end, you could always deploy a secondary contract to work with your D app. That's possible as well, though I don't quite see the reason why people would do that. So yeah, you can try larger number, different numbers. There's no real limit to it, I would say. After a contract is optimized, minified, does it? No. So the optimization just does some funky low-level things on the bytecode stack. So essentially, if you were to verify your contract, I mean, all of us, we don't really read bytecode as much. So as long as you can like reproduce back the same parameters and verify it, then that should be fine. You can show people what's the actual source code itself. All right, I'll move on. Okay, there's one very interesting question. Whether a contract address can be a wallet address or not. I'm assuming that the wallet address is what we call an externally owned account, an account with a private key. Okay, so this is the interesting thing. In all cases of talking about ECDSA, what we use for Ethereum addresses, there's something called collision. So actually, it's possible to end up with an address which is also a contract address. So I can have a wallet, and some random guy would be like 10 years, 20 years down the road would end up being able to create a contract address, which is my wallet. It's possible. Actually, it's 2 by the factor of 80. That's sort of because 2 by the factor of 80 of a chance for you to get it, probabilities and everything. Actually, it's possible. There is a specific EIP which some of the researchers, they are recommending to push. That just came out in CoreDev yesterday. Let me get the EIP. The idea of the EIP is simply to prevent a contract which contains bytecode from being able to push, or historically which had bytecode, from being able to push any sort of like EOA types of transactions. So, okay. So in essence, yeah, it's actually possible. It's a huge number. It's less likely to happen, but it can happen. All right, I think I covered all the questions, unless anyone else might have something to ask Zichuan or myself.
Philip, can you expand a little bit more on, let's say, smart contract wallets like Argent and so on, because they are technically wallets.
Oh, the only thing I can expand is try them out. Yeah, awesome. Yeah, Argent is cool. It's I mean, for example, I'm a user of Noxys multisig as well. Yeah, I guess it's something which you have to try to be able to experience it. It's nice. I mean, you get additional security features. There's like things like you'll be able to add trusted addresses. If it's sending to a non-trusted address, then you need like 2 out of 3 sort of like multi-sig feature. You have recovery features as well. Yeah, just give it a try. It's essentially a contract which has certain rules specified to it. When can you send? How can you send? What's the amount you can send? It's code.
Yep. And to clarify, there is one downside where typically airdrops you might not get if you use a smart contract wallet. I believe so.
Yeah, I think Arjun had that issue with Uniswap. Yeah. Is it Uniswap? I think it's Uniswap. Yeah.
Yep.
Do all your aping on a separate EOA and rest.
Okay, so if there are no more questions, I think we can let Chichuan and Caleb go for now. For those of you who joined, and if you feel like it's worth supporting initiatives like this, you can donate to this EKL address, and yeah, we'll use it for different initiatives like the Crypto Duit Raya or for potentially doing more workshops like this.